And I would like to invite Anna Jędrzejek to talk about satellite monitoring for agricultural drought.
Hello, everybody. Can you hear me?
Yes, we can hear you. We just need your presentation. We have full screen. Everything is fine.
Okay. Hello, everybody. I would like talk about satellite monitoring for agriculture drought. Copernicus is the most ambitious Earth observation program to date. This initiative is headed by the European Commission in partnership with the European Space Agency. The Sentinels provide a unique set of observation and the data are free of charge. Copernicus became fully operational in 2014 and is consequently under expansion with new satellites. Currently, 7 missions are in progress under the Copernicus program. These missions are called Sentinels. Sentinel-1 and Sentinel-2 provide high-resolution data for land and ocean observation. Sentinel-3 provides supports for global land and ocean observation. Sentinel-4 and 5 provide data on atmospheric composition. Sentinel-6 was designed to measure global sea surface height. Each Sentinel mission is based on a constellation of 2 satellites to fulfill and revisit the coverage requirements for each mission. In preparation are 6 pure candidate expansion missions. Satellite images for agricultural application have been used for almost 50 years. Satellite images allowed us to monitor natural phenomena such as drought monitoring, yield forecasting, crop identification, both in the time and space. But until now, monitoring large agricultural area has been very expensive. Providing Sentinel mission data for free use has changed this situation. Sentinel-1 and Sentinel-2 high-resolution satellite images allowed for permanent monitoring even of a single agricultural field in time and space. On this slide shows the comparison between the resolution of images from the Sentinel mission and some examples of high-resolution commercial images across crop fields of different size. Sentinel-2 mission was designed to provide high-resolution optical images for land monitoring, but availability depends on weather condition, while Sentinel-1 mission provides high-resolution radar images in all weather conditions. This synergy of these 2 types of data creates opportunities for Earth observation that have never existed before. Today, we have many different vegetation indices used for agricultural drought, and new ones are being developed all the time. The oldest and the most popular vegetation index is the normalized difference in vegetation index, used widely in agriculture to observe the dynamics of vegetation. At our department, we are conducting research regarding agricultural drought remote sensing. In the article Agricultural Drought Monitoring System in Poland, Farmers' Assessments versus Monitoring Results, we analyzed how agricultural drought was seen from satellite and how farmers estimate their crop losses. The study area was the West Pomeranian Voivodeship in 2021, where the drought monitoring conducted at our institute found the highest yield losses. For comparison, we select winter wheat fields that farmers had reported through the government's drought application. In these two graphs, you can see the relationship between yield losses determined by agricultural drought monitoring and by farmers, with NDVI max after 10 June 2021, according to soil drought sensitive categories. When we exploring the relationship between farmers' declaration and the vegetation condition, we found no cause and effect relationships. This is due to farmers overestimating their losses. When exploring this relationship between monitoring results and vegetation condition, we observed weak correlation. This may be caused by the fact that the vegetation condition depends not only on the soil and weather, but also on a wide range of agrotechnical treatments performed by farmers. In this slide, we can see how agrotechnical treatments determine the crop's condition. Here, we see two fields with winter triticale with similar soil and weather conditions. The fields on the left was fertilized with manure with proper crop rotation, and the farmer declared a 50% yield reduction. And on the right, the farmers apply mineral filtration and rotate different varieties of cereal and declare 30% yield reduction. Difference in the condition of these two these crops are visible both in the RGB images as well as we comparing the average NDVI values. Also, for the two West Pomeranian districts with the highest and the lowest winter wheat yield losses, we plotted the vegetation pattern using NDWI index. As we can see, the plotted patterns correspond well with losses estimated in agriculture drought monitoring system conducted at our institute. In the next article, exploring the potential use of Sentinel-1 and Sentinel-2 imagery for monitoring winter wheat drought under agricultural drought condition in northwestern Poland, we described the research conducted for all fields with winter wheat in the West Pomeranian Voivodeship. These fields were divided in two datasets with losses below 15%, no effect of drought, and losses above 35% with effect of drought. We studied how agricultural drought can be seen using indices based on the Sentinel-1 and Sentinel-2 satellites. As you can see on the graph C, the difference in vegetation pattern we found for these two datasets. Thank you for attention.